Alright, so let's go ahead and get started with the problem. So I'm going ahead and begin by labeling A and B. I'm going to call A the top of the first hill and B the top of the second hill. I'm doing that because the problem gave me information about the top of the first hill and asked me about information for the top of the second hill. That's how I knew that's what to make A and B. If you ever pick something and you don't have any information, then don't use that as one of your A and B points. I'm going to call the height to be 0 at the ground because that's the most natural, and then we'll come back to that at the end of the problem. Okay, so when I go about solving this, I got to find my potential at A, my potential at B, my kinetic at A, and my kinetic at B. I find my kinetic and potential at A and add them together and set them equal to my kinetic and potential at B. That's how I find conservation of energy. So I start by finding the potential at A. So mgh, m at A is 0.5. G is 9.8 like always. I'm using a positive, not a negative G, because it's just the number, the value for the acceleration of gravity, not the direction. So 9.8, and the height at A is 40. That was what we said it was originally. 4 meters above. So when I solve all that out, I get 19.6 for the potential at A. The kinetic at A is 0 because it's 1/2 mv squared, and the velocity at A is 0. Equals the potential at B, so mass 0.5, G 9.8, height is 3.5 meters above the ground. When I do all that, I get 17.15. And then finally I get my kinetic energy, which is 1/2 times the mass, which is 0.5, so 1/2 times 0.5 times v squared. So now is where I go ahead and work through all the math, except I want to go back and make a point to kind of show you about what happens if you don't make the ground to be 0. So we could solve the math out here and we would get the right answer, but I'm going to go back and do it a different way so that you can see you could get it a different way instead. So the other thing I could do is, instead of calling the ground 0, what if I called something else to be 0? Well, the other two natural choices would either be to call A 0 so that I start at a height of 0, or to call B 0 so that I end at a height of 0. I'm going to go ahead and say I end at a height of 0. So that's going to change my HA and my HB, because my HA is now the height above 0, which it was 4 meters above the ground, but now it's 1/2 meter above B. So my HA becomes 0.5 instead of 4. And my HB was 3.5 meters above the ground, but now it's 0 because HB is at what I'm now calling the ground. And so that's going to change my numbers, but you see it won't change my answer. So if you go back and solve what I set up originally, you'll find hopefully that you get the same thing we're going to get here. So mgh for A, the mass is 0.5, the G is 9.8, and the height is 0.5. When you multiply all those together, you get 0.5 times 9.8 times 0.5. You get 2.45. So that's my potential energy for A. So 2.45. Plus my kinetic at A, which is still 0 because the velocity is still 0. Now where life becomes easier. My potential at at B is mgh. The mass is 0.5, G is 9.8, but the height at B is 0. So that means my potential at B is just 0. And my kinetic at B hasn't changed because the kinetic energy is not impacted at all by the potential, because potential is height above some 0. Well, kinetic is just speed, and the speed hasn't changed. So plus 1/2 times 0.5 is 0.25. I'm just simplifying here, v squared. So notice that the math is a little bit easier here. So by picking a little bit harder height of 0 value, I made the math a little bit easier. But I'm going to get the same answer either way. If I divide both sides by 0.25, when I do 2.45 divided by 0.25, I get 9.8 equals v squared. I'm going to square root both sides to get v by itself. And when I do that, I get my final answer, which is 3.13. If I had called A to start at 0, I would get 0 for my potential at A. I would still get 0 for my kinetic at A. I would get a negative 2.45 for my height for B, potential for B, and I get 0.25. I would add that to the other side. I get the exact same answer. If I solved out the math the first time, I get the exact same answer. So no matter how I set up height of 0, I'm going to get the same answer. So allow this to be something that helps you, but don't let it freak you out. If you're having a hard time figuring out what to make the height of 0, then make the ground 0. You'll be able to solve it. It may be a little bit extra math work, but not very much. And if you can make the height 0 be something else, then use it to help you get an easier math setup for the problem. So go ahead and work on the practice. The practice is homework 1 and 2. Number 1 should be straightforward. The ground will be 0. That's the easiest point for that one. But for number 2, you might try making something else to be 0 than the ground. If you want to make the ground 0, you're more than welcome to. But it might be worth trying to do something a little bit different. Anyway, have an excellent weekend. We'll see you on Monday. We'll go over any questions that you have there.